B, the first B. Oh, on page 38?
The first B on page
this one.
Yeah, that one.
You had it right, see?
No. That's the second.
Oh, first B. Yeah.
So when you added the root 6 and the root 6,
Yep.
was there a coefficient of 1?
Of course. There's always a coefficient of 1 when there isn't a coefficient. Right? Always. Some like 12-year-old at karate class last night punched my glasses off my face and broke them.
Oh, really?
Huh? No. I fixed them. What do you think I am? Some kind of loser? I went and I got a staple from the karate stapler, put it through the hole, wrapped it up, wore my glass for the rest of the class, then went home and went to my stockpile of spare glasses and got out a different screw and put it back together. What do you think I am? A kid? Like I just throw things away and get new ones? No. I'm not made of money. But anyway, I fixed them. Stupid kid. Doing something he'd never done before, of course. Kids. He's got a black belt. He's got a junior black belt. I don't know how he had never done what we were doing before. I've done it like a bazillion times. And do it in my sleep. But that kid... And he hit me like 3 times. The first 2 didn't break my glass. It was the third one that did. I was cool about it. I was like, kid, sort this out, man. Kid, because if I take my glasses off, I can't see very well. And if you're hitting at people and you can't see, and if I hit someone, it's going to hurt them. I know this because I punched my wife in the nose more than once. At karate! Damn it, that's recording! At karate! She has punched me in the nose many, many times at karate as well. Shut up. Gonna have to edit that out, I guess. I don't actually know how to do that, but one day I should learn to edit. Huh? I'm sure it is, but usually I don't care. But broadcasting on the internet that, I often punch my wife in the nose, probably isn't a good idea. At karate. She's wearing a face thing and we have things on our fists. It still hurts. No. Yeah, I punch her right in the nose. Anyway. What did all this start? Oh yeah, a kid that broke my glasses, little punk. Anyway. Okay. So, yes, needless to say, I was back at karate last night for the first time in a long time. My arms are a little bruised up because it was beat each other in the arm day. They call it limb training, but it's not really. It's just whack each other's arms together. All right, we good? Any questiones with multiplying? We can all multiply radicals. We can all still do FOIL. All right. Now, eventually, when we are dividing radicals, we must do FOIL. So what we are doing the last 2 days over here comes back to get us over here with the new stuff that we're doing now. Everybody good? Okay. So let us move on then. We are starting with the easy stuff. Dividing radicals with monomial denominators. First of all, I need to make sure everybody knows what a monomial is. The last time you discussed monomials was probably the ninth grade. What is a monomial? A polynomial with one term, right? What makes it a term? So I'm going to go ahead and write that. A monomial is a one-term polynomial. Pardon me? There's no addition or subtraction, only multiplying, okay? So I give that definition. Everyone's like, oh, yeah, I got it, no problem. But then I write this, 3xyz. Is that a monomial? And half the class says, no, because it's got 3 things, x, y, and z. That is a monomial because it's got no adding and subtracting. Everybody cool? So everything we do today, the denominator is going to be a monomial. And a monomial can be as 100 term, or not terms, 100 items long as they're all multiplied. Everybody cool? Yeah? Okay. Now, dividing radicals starts very similarly to multiplying radicals. We borrow some knowledge from fractions, though, because fractions are just dividing. All right? So you all know that x times y equals xy. You all know that root x times root y equals root xy. You all know that, yes? Now, it's the same thing in division. X over y means x divided by y. Now, if it works out perfectly, we can do this, yes? What would you do with this? 18 over 6. That's 3. Why is it 3? Because 18 divides into 6 even groups of 3. Yes? And it's division. Cool? Now, what if I had 18 over 5? As a fraction, what would we do with that? You could make it a mixed fraction, but if we were going to leave it as a fraction, can I do anything more with that? No. Why? Because it's in simplest form. It doesn't get any easier. I can't divide that because I can't do 18 divided by 5 evenly. So you all know how to handle that, yes? This is in simplest form. Okay. Well, what if I gave you 36 over 10? What would you do with that? I would make it simplest form, which happens to be 18 over 5. Everybody cool? Okay. So knowing all this stuff that you already know, guess what the root of 16 over the root of 8 would be. Root 2. Easy peasy lemon squeezy. Cool? Because it divides, we can leave it alone. Now you guys are smart kids. Take it one step further. 4 over 2. What's that going to be? 2 root 2. Everybody cool? Now, every single thing you know about fractions, you still need here. Okay? So what would happen, do you think, if I gave you this? 10 over 4 root 15 over root 5. What do you think you're going to get there? Okay, so Nav has gone to a decimal, and that's okay. And then root what? 3. Cool. Did he have to do 2.5? If you're in math class, do we ever want that to be a decimal? Almost never. In physics, we want decimals. What do we want in math? Fractions. So this would be 5 halves root 3. Right? Everybody cool there? Now, there's one more way to write this, and this is what I need from you guys to understand this. Is this root 3 a numerator or a denominator? Numerator. So this is also 5 root 3 over 2. Is everybody cool with the basics? All right. Now let's remember. Yes, Calvin. Not really. I prefer these, right? But I prefer them because I know that you guys prefer that to 5 halves root 3. You guys like this better, usually. That's just in my experience. Now, and I find this easier to work with. Kind of like when you have a negative fraction, right? I like to just bring the negative always up to the numerator so it doesn't mess with my head. Now, all other rules from math apply. all fraction rules, all exponent laws, all simplification rules, everything still applies, okay? So let's start with this super easy one that you've already done one of. I've already given you one just like this first one. This is technically 9 over 3 times root 18 over root 6. Right? Because it's 9 times 18, 3 times 6. That's what that means, yeah? Now, if I asked you to simplify this, you can do that in your head. You don't need anything special. 9 divided by 3 is 3. Root 18 divided by root 6 is root 3. Because everything works, we can leave it like that. Everybody good? Yeah? All right. Now look at this next problem. It looks weird, but it isn't. I need the square root of everything under there, yes? So do you know something about the radicand there? Look at the radicand, which is this whole thing. Is there something you would do with that if we did not have this 15 and this radical sign there? What would you do with that? You'd simplify it, right? You would divide the numbers and you would subtract the exponents. Yes? Now, this is what bothers me when I'm teaching math to you guys. You guys obviously look at this, and it's an easy one. You got it. But when we go further on, you're going to look at stuff and you'll be like, oh my God, I have no idea what to do there. And you'll freeze. And that is what I don't understand. Because if you're going to walk 1,000 miles, you got to take one step, right? Then it's pretty easy what the next step is. Another step. The next step leads you on. So this question here, you're going to do 15. You're not even going to touch the 15 in the root. Not even going to touch it. You're going to look at this first. And this is 15 over 3, x cubed over x, and y squared over y squared, isn't it? What's 15 over 3? 5. X cubed over x is x squared. Y squared over y squared is what? Cancels. So this is what I have now, yeah? Now, before we started all this, I said all our fraction rules, all our simplification rules, all of the other reindeer, all of our rules apply here. You guys are smart kids. Square root means I'm looking for groups of what size fraction? Groups of 2. Is there a group of 2 factors under there? What? X. Because there's 2 x's. So what is the square root of x squared? X. So what comes out? X. What's already out there? 15x. And what did we leave under there? 5. Is everybody cool? Okay, that is the easy stuff. All right? That's the basic stuff that you already know. Like, even if I didn't talk at all today, if I just said, figure that one out, most of you would have sat down together, and some of you guys would say, oh, we can simplify inside here. Oh, yeah. And somebody else would have said, oh, but there's two x's there. There's a square root. Duh. You would have figured it out, right? Okay. When we get to C, it starts getting a little funky. Why is C difficult? What is weird about it? 1, 2, and 3 don't work. What else? Square root of 6 and 7 doesn't work, does it? Right? Can't simplify that. So we go to all of our other rules. Okay, well, 2/3 is simplest form. 6/7 is simplest form. So now we're stuck at something new, right? The new thing is this. How many of you, hopefully some of you remember, what is the definition of a rational number? What must a rational number be? It has some rules about it. Do any of you remember what those rules are? Pardon? You have to be able to write it as a fraction, yes? Okay. So a rational number has to be x over y. Are there any other rules about it? Kelvin. Y cannot equal 0. Excellent. Are there any other rules about it? I'm only talking about rational numbers right now. Lucas? X and Y have to be something. Do any of you remember? It's okay if you don't. It's one of those stupid little math things that the only reason it exists is to explain what we're about to do now. Okay, X and Y must be integers. And an integer is negative infinity up to positive infinity with no decimals. So I have to have a number over a number. Everybody cool? Do I have that here?
Yeah.
I do. Is that number over number? 2 over 3 is. Is root 6 over root 7? No. Why? Because it's a decimal that goes for how long? Forever. These are irrational numbers, aren't they? So if by definition the root of 6 and the root of 7 are irrational, can I leave them in this form that is the form for rational numbers? Does that make any degree of sense? No, it doesn't. So what I'm saying to you now, if you don't understand all the technical stuff I just talked about, that's cool. Remember this. No radical denominators. That is the key. And the reason is everything I just said. If you don't care about the reason, remember that. You're never allowed to have a radical in the denominator. So I look at this question right away and I see that that radical is in the denominator, right? Okay, how do you get rid of a radical? You multiply it by itself. You square it, right? We know that from our multiplying lesson yesterday. Square root of x times square root of x is x. Gets rid of the radical. So I'm going to get rid of the radical that's not allowed there. What radical isn't allowed? Is the 3 allowed? Only the 7's not allowed, yes? So if I multiply that by root 7, does that help me out? Everyone agree? But what's got to be up here? Lucas says it's got to be root 7. Why? What I do to the bottom, I have to do to the top, which comes from our fraction rules, yes? And here's another thing. What is root 7 over root 7? Isn't that 1? And multiplying anything by 1, does it change a value? No. So even though I'm multiplying by something and it's going to look different, is it going to be worth the same? Yeah. So now we got to go back to yesterday's work. Does the 2 have anything here? So it's 2. What's my new radical? 42. Everybody cool? Over. Does the 3 have anything here? No. So it's 3. Root 7 times root 7 is 7. 2 root 42 over what? 21. Is that okay? Yes. Now, some of you should be saying, but Mr. Myers, that's still irrational. Why is that allowed? Because you said x and y have to be integers. Right? Right? I said that. And to be perfectly honest with you, I am not going to lie. Nobody has ever told me why this is okay and this isn't. Ever. All my math profs, ever. First of all, nobody, they just never tell you. I've never bothered to research it because I was too busy. Oh my God, I have to deal with another denominator. I don't know why. I'm more than willing to research if any of you care. But no, because it's a short day. We don't have time for that. This process is called rationalizing, Mr. Myers, rationalizing the denominator. And that you must do because you are not allowed a radical denominator. Apparently radical numerators are okay. Nobody's told me why, so I just believe them. Everybody cool? So let's look at our next question. What do I have to do there? What's ugly? The root 6. 14's okay, but the root 6 isn't allowed, is it? So what do I got to do to get rid of root 6? I got to multiply by root 6. And if I multiply the bottom by root 6, I got to multiply the top by root 6, yes? So what do I get? 7 root 30 over 14 times 6. 7 root 30 over 14 times 6 is 84. Everyone agree? Is 14 times 6 84? Yeah? Okay. Can I stop there? Lucas. 7 and 84 work together, don't they? To get root 30 over 12. Is everybody cool? Please notice the only new thing we've done today is this term, because we already know how to multiply radicals, don't we? We've done one new thing today. Everything else is old news. Okay? Now you guys are also smart kids. Simplify, simplify, simplify. What should you do there first? Simplify, right? What does root 50 become? 25 times 2, yeah? So out comes what? 5. So I really have 30 root 2 over, what's 18 really? 9 times 2. So what comes out? 3. There's already a 5 out there, so I got 15 root 2, yeah? Root 2 over root 2, what do you get to do? Cancel. No, it's gone. Root 2 divided by root 2 is 1, right? 30 divided by 15 is 2. Oh, I see. Everybody cool? There's no tricks. Not yet. Is everybody comfortable? Remember, all math rules apply. Negatives, simplifying, letters, exponent division, everything applies. Right? You guys do the next 2. Next 3, I lie, on your own. You can talk. You don't have to. When I say on your own, I don't mean it's like a test. Go ahead and try them. That's the worst, hey, Joel, when people take stuff out of context. I know, that's the problem with your guys' whole generation, man. You can't tweet context. You can't Instagram context. You can't...
Right now.
No, you can't.
Yeah, you can.
That is why the way you guys communicate causes trouble. That is why a conversation that would take 5 seconds to have like this takes an hour and a half. I will drive from here to Chilliwack with my wife, and I will say to her, we need to meet so-and-so at such and such time. And she'll say, okay, I'm on it. And she'll start texting here. Can you meet us at blah, blah, blah? Well, no, I don't think I can. Well, what about here? No, I don't think I can. What about here? No, we can't make that. And then I rip the phone out of her hand. I push call. Beck, we need to meet here. I can't do it. What about here? Yeah? Okay, click.
You're not supposed to be on the phone.
I don't care. Here's why, Kelvin. As my wife takes an hour and a half to have a 2-second conversation, I start seething with rage. And you shouldn't drive angry either. All right, so this first one, what is it? What's the first one? -2 root 3. Why? Because 12 divided by -6 is -2. 51 divided by 17 is 3. It works. Always check the easy stuff, Michaela. Let's look at the next one. Oh, hey. Simplify. Myers says simplify. Okay, that's 25 times 2 and move it. No. Try the easy stuff first. 4 and 8 is 1 over 2. Root 50 and root 10 is root 5, right? So 1 root 5 over 2. We never write 1. Root 5 over 2. Yeah? And what's this one? This one's barf-tastic. Because 27 over 10 does not simplify, does it? No. But it's all square rooted, isn't it? So isn't that root 27 over root 10? Everyone okay with that? What about that is ugly? Radical in the denominator. We don't like that, do we? And there's another thing that's ugly there. What else is ugly? 27 simplifies, right? So this is really, what's 27? 9 times 3, yeah? What's the square root of 9? So out comes 3. So I've got 3 root 3 over root 10. Now what's ugly? Root 10. So what do I do to get rid of it, Jessica? What do I do to get rid of it? Times by root 10, times by root 10. Now I've got 3 root 30 over 10. Is that okay? Why? Root 30 is a big number. Shouldn't I simplify it? But I can't, because it's 2 times 3 times 5, right? No pairs. All the rules apply. Is everybody cool with the basics? I have an answer.
If, like, let's say for H, you actually decided, or not decided, but just forgot how to do it,
Yeah.
would you still get the same answer?
Well, let's look at that, Joel. That's a good question. So that is 25 times 2, yeah?
Yeah.
So that's going to be 20 root 2 over 8 root 10, yeah? Agreed?
Yes.
Okay. So 20 over 8 reduces, or simplifies, I lie. 4 goes into both of them, right? I'm going to get 5 over 2, yeah? Right? 5 root 2 over root 10. Can't simplify that anymore, yeah? Right? Because 2 and 10, I can't simplify those. Cool? Okay, just one sec, Nav. So what are you going to do to get rid of that root 10? Times by root 10. Root 10, root 10. So that's going to be 5 root 20 over 2 times 10, yes? Which is going to be, that simplifies to 10 root 2, yeah? Over 20, right? 10 divided by 20 is 1/2, yeah? So I'm left with root 2 over 2. Now, what's weird here? Okay, one sec. Let me talk to Nav, because he stopped me way back here. Nav, what are you on about?
When you said you can't simplify root 2 over root 10,
Mm-hmm.
isn't 2 over 10 1 over 5? So
Yeah, of course it is.
theoretically, could you do that?
Yes.
So you could do,
So I would end up with root 5 on the bottom. And then it works. I just got no groove. Yeah, you're going to get the same thing. So sorry, I should have stopped here when I would instead of yakking, right? That's 5 root 1 over 2 root 5, right? Which is 5, because root 1 of 1 over 2 root 5 times root 5 over root 5. Okay? And then you're good. All right. Everybody's cool? Okay, do page 41, I believe. Huh? Well, it's 10:57. I can't remember when lunch begins. 11:30. We should be able to get this done. You guys, I don't want you to have homework tonight because I'm giving you a quiz tomorrow. I'd like you to study for it. Huh? I wrote it on the board. It's been up there for days. Not my problem. You want? Oh yeah, Nav. There's a reason this is recorded for guys like you. Nav, listen to me. I look gray-haired and I look old. My memory ain't going nowhere. I know everything I've said to you. And just for proof, I keep it here. You can ask people that have been in my class before. At the end of the year, Mr. Murray, you never taught us that. Oh, really? Boop, 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 boop. There it is. It is really annoying. You know what's really annoying for the teacher? Mr. Myers, you didn't teach us this. What's the real sentence? Mr. Myers, I didn't learn this. But you guys aren't ever at fault. It's always someone else's fault. That's part of being a millennial. You inherited a bum world. Oh, muffin. I inherited the bum world a long time before you did. So I'm going to... Do not ask how to do a question, because I might go down a different path than you do. You might just do it in a different order. Okay? Learn the concepts you need to solve the problems. Please understand the difference. You are getting to the end. Actually, it started at the end of grade 9. You are getting to the end of this is how you do it to this is what you need to do. Okay? So this next one, I simplify right away, right? That's 4 times 6. So that's 36 root 6 over. That's 81 times 2. So that's 9 root 2. 36 divided by 9 is 4. Root 6 divided by root 2 is root 3. Cool? This one we already did. 9 divided by 3 is 3. 20 divided by 2 is root 10. 3 divided by 3 is 1. 10 divided by 2 is root 5. Okay? I didn't need to rationalize because the denominators all disappeared. Now, could I have rationalized here? Could I have gone times root 2 over root 2, distributed that root 2 in, simplified? I would have gotten the same answer. Right? Because on the bottom, I would have had 3 times 2, which would have been 6. And on the top, I would have ended up with 18 and 6. Everybody cool? Okay, should I do the next 4 or? Yeah. All right. This one doesn't simplify. So what's ugly? I got to rationalize. That's root 60 over 5, yeah? Does root 60 simplify? Yeah, because it's 4 times 15, right? So it's 2 root 15 over 5. Cool? All right. What about this guy? What's ugly? The root 6. Is the 5 okay? 5 can be down there, right? So I'm only going to multiply by root 6 and root 6. So I get 2 root 6 over what's 5 times 6? 30. 2 over 30. Does that simplify? to what? 1 over 15. So it's root 6 over 15. Everybody cool? Okay. What's yucky here? I don't like that radical down there, but that radical itself is yucky, isn't it? Simplify, simplify, simplify. That's 4 times 22, right? Right? 4's got a root, so this is negative 2 over 2 root 22. What's ugly? Root 22, root 22. Negative 2 root 22 over 44, right? And that simplifies to what? Negative root 22 over 22. Everybody cool? Now, could I have rationalized right away with 88? Yeah, and then I just simplify 88 later. It's just a bigger number to simplify. See what I mean about there being no right way to do it? There's right principles you need to apply, but there's no right order in which to do them. Understand? Except for all the regular rules of math, like BEDMAS and all that. So, this one's barfy. Simplify, right? 500 is what? 100 times 5, yeah? So out comes a 10. So I got 30 root 5 over negative 3 root 3. Yes? What's 30 divided by negative 3? Negative 10 root 5 over root 3, right? Is that allowed? So I multiply by root 3, and I get negative 10 root 15 over 3. Everybody cool? Now, as Michaela says, it's a lot of grunt work, yeah? Like it's a lot of arithmetic to do math, right? You just got to keep at it. According to the grade 9 textbook. But it does make sense because the rules are always the same. Like everybody gives math a hard time, but math is really the only thing you do that is always the same. It doesn't matter what it looks like, we can follow the same rules. Now, this is where it starts getting hairy. How many people have gotten to this A? Just a couple? Should we go through it? Okay, so what's ugly there? You don't like the bottom, right? Now there's a couple of things you can do here. If you've been memorizing steps, then you may have gone times root 2 over root 2. And that's okay. You're going to get root 14 minus, what's root 2 times root 2? 2 over what? 2. Can't do that, but what's 2 divided by 2? 1. So this is really root 14 over 2 minus 1. Could you leave it like this, though? Is that okay? Yes. They're both the same thing. I don't care. Now look at the next one. There's no simplifying, is there? What's not allowed on the bottom? Just the radical. So do I care about the 2? No. So I'm going to multiply by root 3 over root 3. And I'm going to get, on the bottom, what's 2 times 3? 6. And on the top, I'm going to get what's root 3 times root 3? 3 plus 2 root 2 times root 3? 2 root 6, yes? Does that get any tidier? Now, can I leave it like that? Sure, I can. But you could go one step further, couldn't you? Because 3, 6, 2 all work together, yes? This is really 3 over 6 plus 2 root 6 over 6, right? Yeah? Which is 1/2 plus 1/3 or root 6 over 3. Hey. Now,
You know, the very first step could be like could be separated like root 3 over
yes,
root 3 and then cut out the root 3.
yes. That's the point I'm trying to make, Nav.
No, like I just wanted to.
Yeah, there isn't a right or wrong way. So you guys finish that, and then you need to be ready for your quiz tomorrow, because the bell is about to ring. Well, not really. You got a bit of time. Is it 9 minutes? Really?
They said 11:30. So.
Lunch is at 11:31. It's 10 minutes.
I did. I started like 18. My dad's kind of taking this
You too.